All right. Let's take a look. I think all we have left is the word problems. And then you have that handout that we've been working on for days and days. And you should just have the word problems left. And tomorrow we will probably take one more day, and I'm going to give you another handout just practicing all this because there's been so much stuff in this section really. Transformations and compositions and domains and word problems. So tomorrow I'm just going to give you a handout and give you the day to work and ask questions on that. And then we will have one topic left before our first test. So, here's the game plan here. So this problem says a spherical balloon is being inflated and the radius of the balloon is increasing at a rate of 2 centimeters per second. So part A, express the radius of the balloon as a function of the time t in seconds. All right, so real quick, express the radius as a function. So what variable is radius? But it's in, the radius is in the y value, right? And that means that my time is the x. So they're not really asking for just an ordered pair here. They're asking for an equation. If you think about it in function notation, if you want to do that, that's saying r of t, the radius as a function of time. But we're trying to come up with some equation for how we would get the radius just based on the time. So let's go back and look. So it's being inflated, and the radius is increasing at a rate of 2 centimeters per second. So at time 0, how big is the radius? 0. After 1 second, what would the radius be? 2. After 2 seconds, the radius goes up 2 more, so it would be 4. After 3 seconds, the radius would be 6. After 4 seconds, the radius would be 8. Can you figure out how I'm finding the radius every time? What would my equation be? T times 2, or 2t. So my radius is just 2t. That's all part A was. B. If V is the volume of the balloon as a function of the radius, find V composed with R and interpret it. So we are talking about volume. The balloon was a sphere, so we need volume of a sphere. That may not be a formula you know off the top of your head. Just as a side note, your textbooks have a lot of formulas in the back. There are these like heavier pages, and so you can look like sphere, volume is 4/3 pi r cubed. That would be a formula on a test or quiz I would give you, but in class on homework, you have this available to you. So in general, volume of a sphere is 4/3 pi r cubed. I want you to find V composed with R. That's asking for V of R of t. So that's telling me in this equation, what am I going to replace my R with? 2t. Alright, so if I wanted to simplify this, 2 to the third is 8, t to the third, so 8 times 4/3 would be 32 over 3 pi t cubed. it tells me that I need to interpret this. That's like writing a sentence. So what does this volume, or what does this formula find? The volume, what do I have to know in order to calculate the volume for this? Time. So this gives the volume. During a given time. Basically, it cuts out the middle step. If I tell you that it's been inflated for 5 seconds, you don't have to first find the radius and then plug the radius into the volume formula. You can just plug a 5 into this formula and get the volume at that particular point in time. So it's just giving us the volume at any given point in time. Let's do another one together before I have you guys try one. An airplane is flying at a speed of 350 miles per hour at an altitude of 1 mile and passes directly over a radar station at time 0. So here's my radar station. Okay, the altitude is the height. Did it tell us the altitude is changing? So we're going to assume the plane is flying level. So this is not a variable, it is a given height of 1 mile. And then my plane is flying here. So your excellent art skills come into play. Here's my plane. So part A, I want the horizontal distance d in miles the plane has flown as a function of time t. So I want d as a function of time. I want an equation for that distance using time as my variable. So what would it be? At time 0, how far is the plane flown? Well, at time 0, we're going to start it at 0. So we want the distance it's flown since it began. So at time 0, we're starting at 0. So after 1 hour, how far did it fly? 350 miles. After 2 hours, 700. After 3 hours, 1,050, and so forth. So how do I find my distance? The previous one plus 350. So 0, 0. Oops. And the time is 1. This is 350. And the time is 2, it was 700. Time is 3, it was 1,050. Yes. So 350 miles per hour. So 350 times t. Okay. B. Express the distance s between the plane and the radar station as a function of d. Alright, let's look. So s, I don't have in my picture even, but it's distance from my plane to my radar station. What kind of triangle did I just draw? Right triangle. What formula do we use a lot in right triangles? Pythagorean theorem. A squared plus b squared equals c squared. C has to be the hypotenuse. In this case, it would be 1 squared.
May I have everyone's attention, please? The following is just a...
So we know this. And I said we're finding s as a function of d. So we're solving for s, but d is going to be the variable that I keep in here. So what would I have to do to get the s by itself? Square root. With that, we typically do a plus and minus, but could my s be a negative in this scenario? No, because it's a distance. So 1 squared is 1 plus d squared. You cannot do the square root of each of those individually. So that is our answer. C, use composition to express s as a function of t. So this means I want an equation for s, but I need t to be the variable. So what am I going to do? Yeah, I need to replace my d with 350t. Now make sure that square applies to both of those. Like this. Now if you wanted to, you could square the 350, but it's not going to simplify anything else. So we can just leave it like that.
Thank you for your participation.
So an oil tanker crashed into an iceberg and has developed a leak. The radius of the spill is increasing 1.5 inches per second and has a constant depth of 1 inch. So A, the radius as a function of time. So an equation for radius with time as the variable. What is it? B, volume. So I told you volume of, this would be like a cylinder. So that's area of the base, pi r squared times your height. But we know the depth is constantly 1. So we are looking for the volume as a function of t. So pi, what do I plug in for my r? 1.5t squared, and my height is always 1. So there's different ways you can write it. You could do 1.5 square that, t squared. 1.5 is the same as 3 over 2, so you could say 9 over 4 pi t squared, as long as you have something equivalent. If you squared the 1.5, what would you get there? Yep, 2.25 pi t squared. So lots of ways you might have written that equation. It just has to work. All right, so interpret the composition. So the formula gives the volume at any given point in time. Is that okay? Try the last one. So a stone is dropped in the lake, creating a circular ripple that travels outward at a speed of 46 centimeters per second. So the radius as a function of time would be what? Okay, B, we want area. So area of a circle is what? So we want the area as a function of the radius. Well, that should have said area as a function of time. Sorry about that. So the area is a function of time. So pi, my r is 46t squared. What is 46 squared? It's not pretty. What'd you say? Pi t squared. So what's this give us? The area of the circle at any given time. Okay. So we have quite a bit of time left, maybe more than you need, but I'm sure you won't be too upset over that. So you have that worksheet. There are only a couple word problems on it, so if you've been keeping up each day, it may not take you too long. But if you get done, go ahead and check everything, see if you have questions, okay? So you have the rest of the time to finish that handout.